All right, so function notation. So to write, or it says to denote that y is a function of x, we can write y is equal to f of x. Okay, y is equal to f of x. So instead of writing y, we're going to write f, open parenthesis, x, close parenthesis, comma, read as f of x. This is a function notation where f is the name of the function. For example, the notation f of 4 means to replace x with 4 in the function. So let's talk about this a little bit more. We have here the example. Given the function g of x is equal to 2x squared plus 3, it says find the indicated values. So what this is saying here, as far as, just talk about this for a second. Here you have a function called g of x is equal to 2x squared plus 3. This is what we called a function notation. Okay? Now, if I said y is equal to 2x squared plus 3, then we just have an equation where it's solved for y. It's not a function. Okay? Now, if I just took this exponent of 2 out for a second, we would call this a linear function notation. Whereas where we have y is equal to 2x plus 3, we would call this a linear equation. Well, if you were to graph the 2x plus 3, doesn't matter if it's written as a function notation or with y, your graph is going to be the same exact graph. What I want you to understand is that all we're doing is replacing y with a function of, we're saying here g of x. It's just another name. It doesn't change the fact that if you were to graph this 2x plus 3, it's not going to change the equation at all. But for the first example where it says you have a function g of x is equal to 2x squared plus 3, find the indicated values. Find g of negative 12. Well, what this is saying, this is what you had before, and we're just changing the setup a little bit. Okay, so what you had before, you had something like this: evaluate 2x squared plus 3 when x is equal to negative 12. This is what you had before, so what you would do is substitute negative 12 in for x, then square it, then times 2, then we add 3. You was the end goal substituting negative 12 in for x. Well, that's going to be the same thing for this example here. We're going to substitute 12 in for x into this equation. Excuse me, into this expression. So here you're saying 2 times negative 12 squared plus 3. We're going to square 12, which is 144, times 144. Let me write this out. 2 times 144 plus 3. Then you're saying you're going to times 2 and 144. We have here 288 plus 3. And add 288 plus 3, we have 291. So what this is saying here is that basically you're saying your domain would be x and your range is what is equal to, which would be 291. This is what you're saying. I'm sorry, let me move this up some so you can see it. As an ordered pair, this is what, if I had you to plot this on a number line, then you would plot negative 12 comma 291. Okay, so 291 is your solution. Let's do the next one. Using the same expression, but we're going to substitute -1 in for x. It says find g of -1. Here's the expression again, 2 times x squared plus 3. So we have 2 times -1 squared plus 3. Square your -1. -1 times -1, which is positive 1, plus 3. Multiply 2 times 1, we have 2 plus 3, and that would give us 5. Therefore, so when you see me write 3 dots, it means therefore. Therefore, g of -1, your x value, will equal to positive 5. That will be your y value. Okay? Letter C. We're going to substitute 1/2 in for x. So we have here 2 times the quantity of 1/2 squared plus 3. We're going to square 1/2. That means we're going to multiply 1/2 times 1/2. This is what we're doing. So you're going to get 1/4. So we have 2 times 1/4 plus 3. That would give us 2/4 plus 3. Now, if you want to, you can reduce that 2/4, which would be 1/2 plus 3. And we want to convert, now we have a fraction plus a whole number. So let's convert this 3 into a fraction. To do so, we're going to place a 1 under that. And we want to convert 3 into halves. So what must we multiply 3 over 1 to get it into halves? That would be a 2. So now you have 1/2 plus, that's going to be 6, 6 halves over 2, or 6 over 2. And we have here 7 halves. Therefore, g of 1/2 is equal to 7 over 2. So you have an input value of 1/2, and then your output, meaning that what is it equal to, it will be 7 over 2.